Hi, everyone. Thank you for joining us today. My name is Pashmin Mistry, and I'm the product manager in the Computer Vision organization at AWS, responsible for the Amazon Rekognition Custom Labels service. Along with me, I have two special guests. Stephen Main. Stephen is an AI services solutions architect. In addition to Stephen, I would also like to introduce you to Bree, one of our coworkers. Together, we will educate you on our experience with Amazon Rekognition Custom Labels. So, who is Bree? Bree is a rescue dog, and her DNA makeup was a complete mystery to us. But we were really interested to know more about what sorts of breeds contributed to her genetic makeup. We don't know everything about Bree, but we do know something. We do know that she really enjoys playing with sticks. She will eat just about anything that gets in her way. She also has been enjoying having her mom and dad around all day, especially since the lockdown. There are a few things that we don't know about her. For example, why is she so curious all the time? She is always smelling everything, especially when we go around for long walks. She goes absolutely crazy if she ever sees a squirrel. So, in general, we were more interested in knowing more about her. There are these companies that sell doggy DNA tests, but they can cost over $100. So it made Steven and I think, could we train a machine learning model that would tell us what breed Bree is simply by looking at pictures of her? So that's what we did. We trained a computer vision model. We used a really nice data set that is provided by Stanford University that includes images of over 120 breeds of dogs. And we were able to use this data to quickly train a model using Amazon Rekognition Custom Labels. When we uploaded a picture of Bree after training the model, we got a very high confidence score for Skipperkey as Bree's breed. After doing more research on the breed, we found that visually they do look quite alike. They are also known to be very agile, very energetic, and curious. And the name Skipperkey comes from the Flemish word for little captain, and they were used on ships to hunt pests. So, given Bree's behavior around squirrels, it made even more confident that the service correctly predicted the breed of the dog. Bree did end up getting a doggy DNA test, and unsurprisingly, that did show heavy presence of the Skipperkey DNA. So, what's neat about custom labels is that we were able to train this model without writing a single line of code or needing any specialized machine learning knowledge. This is very powerful. This unlocks computer vision technology to be used by developers and data scientists as a fully managed AWS service without having to build their own machine learning model algorithms from the ground up. We do the heavy lifting for you. So, what exactly is Amazon Rekognition Custom Labels? Amazon Rekognition Custom Labels is a feature that allows you to get customized image analysis to easily detect objects and scenes that you find most relevant for your specific domain and business use case. It allows you to train your own computer vision machine learning model using your business specific or domain specific data set. And we'll talk about more in detail in the next few slides. There are few different types of image detection problems in general that are supported. Single label classification, multi-label classification, and object detection. Single label classification is when objects belongs to a single class. For example, which part of the store does this image show? In this case, the label for one image could be pre-made foods section, whereas for another image, a label could be produce label. Multi-label classification is when image may belong to more than one class at the same time. the model will return multiple labels for each image. So in this example, the second image, the model would return labels such as mountains and dusk. The third type of model we handle or we support is object detection. These models don't just indicate the objects that are detected in the image, but will also give you a prediction of where in the image that object was found. So in this image, the model not only detected both Buster and Arthur, but it also indicated via a bounding box the location of both the characters. So let's deep dive into how does Amazon Rekognition Custom Labels work. The first step is to create a data set. We have a user-friendly interface within the AWS console that helps create labeled training data. If you are familiar with other AWS services, you can also import data set from an S3 bucket or use Amazon SageMaker ground truth. You can then go ahead and click a single button. That's right, just one button to get started to train the model using your data set. You don't have to worry about the underlying architectures, algorithms, any hyperparameters, which GPU instances to use, so on and so forth. Being a fully managed service, Amazon Rekognition Custom Labels does the heavy lifting for you. It does this by taking advantage of something called as transfer learning. Transfer learning begins with a base model that has been trained on a very large set of images against a wide variety of classes. This base model understands different concepts that allows it to more quickly and accurately understand the new classes and objects that are found in the customer uploaded dataset. In other words, at AWS, we do the heavy lifting for you. This, therefore, is a fully managed AWS service. For example, Amazon Rekognition Custom Labels builds and trains a model on millions of images which can identify vehicles, such as cars, trucks, and vans. If you want to train a model that identifies specific types of cars, trucks, or vans, it can more quickly learn that since it already has a fundamental understanding of what it's looking at. Importantly, this allows you to train computer vision models with a fraction of the data you would otherwise need to build and train the model yourself. Instead of needing tens and thousands of images, you can get started with tens to hundreds. Once the model is trained and you're satisfied with its accuracy and quality, the deployment is very easy. With a single API call, you begin running inference and prediction with the model that you have trained. Before handing it over to Stephen, I would like to discuss in more detail how Amazon Rekognition Custom Labels is being used by our customers. Here's an example of how Autonet set out on a mission to automate the auto insurance claims process. Most of us, if not all, at some point had to work with an insurance provider. And that can be quite a time-consuming process at times. What Autonet wanted to do was to disrupt the space and use computer vision technology and improve the overall claims adjustment process. They used Amazon Rekognition Custom Labels to assess where, what type, and the level of damage the car has suffered. By doing this, they are able to streamline the process and make this technology available to insurance providers who in turn can deliver a much improved end customer experience. You can read about this use case in more detail along with a technical architecture of the Autonet solution at the blog link on the slide. We will also make it available on the chat for you. The second growing use case that we're seeing is the document classification use case. Document classification is traditionally thought of being done by natural language processing. But there are situations such as with different types of IDs and passports where it doesn't have a lot of text. It has names, numbers, but are visually very distinct. In that case, they can be easily classified using computer vision technology, and Amazon Rekognition Custom Labels can be used to train a model that can very easily classify such documents. The third use case I would like to highlight is around damage detection. Sempra Energy is another customer of ours where they're using custom labels to identify objects of interest from drone footage. Sempra Energy makes use of drones to take images of different electrical poles and grids. They then use custom labels to identify the image itself and detect whether or not it has damage on it. And if they do find some damage, they would also use custom labels to identify what type of damage. When they do find some damage on these images that can pose a fire risk, they would then send somebody out there to take a look. We're seeing a lot of customers leveraging drones in general to take pictures of different objects of interest and then using those images to train a model using custom labels to identify and then classify those images. The fourth use case I would like to highlight where we're seeing growing traction is around the inventory management space. In this case, here is an example where we have trained a model to identify different boxes of cereals in a grocery store aisle. We have seen some customers use this to automate the process of ordering more items as they start seeing the inventory deplete. We have also seen customers use it to ensure their branding guidelines are being followed by the stores and that they are displaying and selling their products in the right way. They can easily have a store personnel snap a picture after the product is placed and positioned and then send it to their automated analysis division, where they then confirm that the right orders, the right products are being displayed in the right order, in the right shelf, and the overall branding guidelines are being met. NFL is one of our referenceable customers who used Amazon Rekognition Custom Labels to identify different types of logos and symbols. They then use that to automatically generate metadata tags for their video content. This enabled them to build a faster and a much richer content search algorithm, which would have been very expensive in terms of time and resources needed if they had to build it themselves and generate these tags manually. With that being said, let me pass it over to Stephen, who will now walk us through the technical details behind this service and give you all a live demo. Stephen, over to you.
So for our demo today, I'm going to go through the process of training one of these Amazon Rekognition Custom Labels models from start to finish so that you can see how easy it really is. So to get started, from the AWS Management Console homepage, I'm going to go in the top here, and I'm just going to type in Rekognition, and I'm going to click the button to go to the Amazon Rekognition homepage. From here, we want to use the Custom Labels service. So I'm going to click on the left-hand side to use Custom Labels. And then I'm going to click this little hamburger icon, and I'm going to click Projects. So for now, I don't have any projects, so we need to create one. And the type of model that we're going to train today is going to be a model that identifies different rooms in a house and classifies them. You can imagine this could be useful for a company that has folks who are either trying to sell their homes or maybe rent their homes temporarily. And so you have lots of user-generated photos that need to be classified. So because this has to do with real estate, I'll just name it a real estate model. And then I'll go ahead and click to create this project. Once we have a project that's been created, we need to create some data sets to train that model on. So I'm going to go in here to create data set, and I need to give my data set a name. So in this case, we'll just name it rooms in house as our data set. Now, the next step is that I need to point this data set to where my images are uploaded. In this case, I'm going to upload my images first to Amazon S3 because it's very easy for me to then import them into a data set. And there's an S3 bucket that is created for us automatically whenever we use Amazon Rekognition Custom Labels. And it's created to ensure that it has the proper permissions to make it as easy as possible to connect S3 with Amazon Rekognition. And so what I'm going to do is click this link, which will launch me into Amazon S3. And this is where I can upload my images. So I'm going to create a folder, and I'm going to call it real estate, and then just scroll down, hit create folder, and then I'll go in here. And what I need to do is I need to then upload my images of the different rooms in my house. So if I go into my file browser here, you can see I have a folder which is called real estate photos. And then inside of this folder, I have a set of subfolders, and each of the subfolders represents a different class that I want my model to be able to understand. So I have a folder named backyard, bathroom, bedroom, etc. And if I click into each one of these folders, for example, if I go into the folder for bedroom, you can see that I have a bunch of images of bedrooms. And so our Rekognition Custom Labels service is going to take a look at these different pictures, and it's going to start to understand what's going on, start to formulate some patterns, and use that transfer learning that Pashmin was talking about earlier to be able to differentiate what makes a bedroom versus what makes a bathroom, and so on. So all I need to do is take this folder and drag and drop it into Amazon S3. And then I'm going to scroll down, and I'm just going to upload all of those pictures. So there's a number of pictures here. So it'll take some time to upload. So what I did ahead of time was I went ahead and I pre-uploaded these so that we don't have to sit here and wait for them to all get uploaded. So I uploaded it in this folder. And so you can see here, we've got the same exact folder structure that was on my local desktop. And what's really nice is that the Rekognition Custom Labels service is going to use these folder names actually to generate labels for my images. So instead of me having to go in one by one for each image and apply that label, it will automatically assume the label based on the folder structure, so I can import all of the images with the labels in a single step. So what I need to do is I just need to go to the parent folder here and copy this S3 URI, and then go back to my Rekognition Custom Labels and paste that in here. And then the next step is to select this box to automatically attach that label to my image based on the folder that it's stored in. And from here, I just need to go ahead and hit the button to submit. And after a few seconds, it's going to import those images in. It's going to give me a nice labeling guide with step-by-step instructions if I need it. But for now, I'm going to exit out of there. And what you can see is our images have been imported, and the labels have also been imported with them. So for example, I can select using these filters on the left to only look at images of the front of my different houses, or similarly, if I wanted to do the same with something like kitchen. So with that being said, the next step then is to actually train a model using this data set that we have. So what I want to do is I'm going to go back to that project that I created earlier, this real estate model. And then I'm going to click this button to train a new model. And for my training set, I'm going to choose that data set that I created earlier, which is called rooms in house. Then we have another step, which is to create a test set. So our training data is the data that's going to be used to actually make the model smarter. But we also want to supply another data set, which is going to be used for evaluating the accuracy of the model. And we don't want to have the pictures that are used for evaluation to also be in our training data set, because then that's giving our model an unfair advantage. It's basically trying to predict what class an image belongs to, but it's already seen that image before. And within Rekognition Custom Labels, there's a very easy way to do this, which is by choosing this option to split our training data set. So it's going to reserve 20% of our images, and it's not going to show them to our model during training, but it'll set them off to the side. And once training is complete, it's going to use that 20% of images as an evaluation set, and it will be able to tell us how accurate our model was able to predict images in that holdout set. So I'm going to choose to use that auto split method and then scroll down to the bottom. And all I have to do is to click train. The nice thing is that I don't have to worry about what algorithms I'm going to choose or tuning any hyperparameters. I don't even have to choose the type of problem that our model is trying to solve. All of that is handled by the Amazon Rekognition Custom Labels service. And now all I have to do is wait a little bit of time for this model to be trained. Thankfully, I've planned ahead a bit. So I've trained a model on this exact data set ahead of time. And I've done that in a different region here. So if I move over, I can show you what the result of this final trained model is. So as you can see, we've got a model that has been trained. It took 1.2 hours to train on that particular data set. And you're able to see that we had an F1 score of 0.993. So 1.0 would be a perfectly trained model. You know, it doesn't make any mistakes. Here you can see we've got very, very close to that. And if you scroll down, you can also see what the score was for each of the different classes. So it seems like across the board, we've done very well. But in one case, you know, with the living space, maybe we've made an incorrect prediction. If I want to view more results to see exactly what my model predicted for all of the images in my test set, I can scroll up here and choose the option to view test results. So these images are the images that were part of that 20% test set that I was talking about earlier. And you can see the labels that were predicted by our model. So in this case, you know, you can see that our model correctly predicted backyard, bathroom, and so on and so forth. And then if I scroll up on the left here, you can also see I have the option to view true positive, false positive, or false negative. So in this case, I'm really curious, what is it that my model predicted that was incorrect? So if I select that I want to look at false positives, then I can see this one image which was slightly incorrectly predicted. So for this particular picture, our model actually could not decide whether this was a bedroom or a living space, which I think, you know, looking at the image, it seems to make sense even as a human being how you could maybe be confused about this big empty bedroom. Is it perhaps a living space? And so in this case, our model has actually made a prediction that it could belong to either one, but it actually only has the one true label, which is bedroom. So in the future, if we wanted to make our model smarter as to not make this mistake again, what we can do is include more images that look like this of empty bedrooms and ensure that our model understands clearly the difference between a bedroom and a living space. So the next step is then, how do I use this model once I've created it, right? So we have this highly accurate model, but I want to actually be able to deploy it into an environment where I can make some inference from it. So what I can do is I can go over to this use model, and you can see that I've already deployed this model and it's in the running state. I have the option here to stop that model as well. And there's also some nice code that shows me how it is that I can interact with this model. So you can either use the AWS CLI, and there's some simple, straightforward, you know, code that you can use to perform inference and get predictions in real time, as well as some Python code, examples that allow you to write some very basic Python code to send new images and get those real-time predictions. So with that being said, since we're talking about putting this into production, I'd like to show you all an architecture diagram so that we can talk about how you can fit Rekognition Custom Labels into your AWS environment. Here is an example architecture of how you can put Rekognition Custom Labels into your AWS environment. It all starts with some sort of camera that is taking pictures or uploading pictures into your AWS environment. And typically customers will take those images and upload them directly into S3, our Amazon Simple Storage service for long-term storage. You then can configure an SQS which is just our simple queue service, so that whenever a new image is uploaded to Amazon S3, it will add that image and metadata about that image to a queue, which will indicate that it needs to be processed by our downstream processes, which will be, in this case, our Lambda function. So our Lambda function can be configured so that whenever a new item is added to our SQS queue, that it triggers a new Lambda invocation. And that Lambda function will then take that image that's stored in Amazon S3 and pass it to the Rekognition Custom Labels service. The Rekognition Custom Labels service will look at that image, and then it will make a prediction about what class that image belongs to in the case of our classification algorithm, or perhaps it will identify the location of objects if you've trained an object detection model. And then it will take that custom labels response and send it back to the Lambda function. The Lambda function can then take that custom labels response from the Amazon Rekognition service and store those into something like Amazon Elasticsearch so that it can be queried by some perhaps user-facing application down the line. So there are other ways that you could play with this architecture. You don't necessarily need to use Lambda. You could use Fargate or EC2. And similarly, you don't have to use Amazon Elasticsearch. You could use something like DynamoDB, or you could use a traditional relational database if you wanted. But this is just to give you an idea of architectures that we've seen work for customers in the past. So with that, I will pass it back over to Pashmin to handle the questions and answers section.
Thanks, Stephen. That was great. I really appreciate everyone joining the webinar today. If you have any questions, please leave them in the chat. We'll be happy to answer them.